Welcome back. In this video I'll be solving Leetcode problem 1780. Check if number is a sum of powers of 3. Given an integer n, return true if it is possible to represent n as the sum of the distinct powers of 3. Otherwise return false. So I have 10 to the 7th. And I have to check if it's sum of numbers of 3. So for this task there is a pretty, let's say, easy solution if you know it, but let's do it in a way that I don't know the solution. So let's see how would I go by with this one. So essentially I know the n, and since I know the n, I know the highest number of 3 I can use. So let's see. Oh, let's go with highest. It's okay. Highest is maybe this works also. So Paul. Let me just check this. Can I do it? Okay. Okay. So that's the highest one I can use. That's the top one I can use, and essentially what I'll check, I'll do the all possible, let's say, bit masks, and I'll try to sum it up. If it's correct, I give true. If it's always false, I give, so return true. And what do I got? So for I in so if I got 2, mm-hmm. 0, 1, and 2. Okay, so I have to go to the 3 possibilities. So I have 8 possibilities. So 0, 1. I think I have to detect this. So for I in range highest, and this is +1, so 0, 1, and 2, but not even this, but 2 to the highest. and I have current is equal 0. So I have I in range, and here I get, let's say, 0. Zero means I don't use any, so it's at least 1. Okay, so it has to be 1. Okay, and now I have to check for each digit, 0th place, 1st place, and so on. So for J in how do I do this? I forgot. So if it's 8, let's say I got 1. And this is number of digits. So for J in range again, this is number of digits. So for J in range, oh, I'm so bad at this. So I get 1, 2, that means 1, 3, that's both of them. 4 as third one. 5, okay. I think it's just highest. Again, plus 1. So current is if I and 1 to the J is not equal 0, print, let's just say so print I and print J. Let me see. I need to really get better at this. Okay, this is what I want. So for this one is 0th bit is used. For 2 only 3rd bit is used. For 3 those two are used. For 4 that one is used. Why did it stop? My input was 21. And I got what? It seems I got this looks good, but I messed something up. I'm not sure what. So for I in range, this could not be. It could be. So 3 is 27. So this is 3. As this is 3. Okay, I think I got it. So cur plus equal 3 to the I, and if cur is equal to n, turn false. So something like this. And why was it false? Oh, my bad. So 3 to the j. Huh? So I missed here. For whatever reason, I missed 12 here. And why exactly did I miss 12? I can. Come on, I'm so bad at this. It's crazy. Crazy how bad I got. But yeah, that's essentially it, and this should work. And I don't even need to go from 1. I can do it just like this. Let me just check it out. Timed out, so not nice, but at least this works. and it seems that I can't actually. Okay. Hmm. This is weird. I thought this would work because in worst case we have 10 to the 7th log 3. So log base 3 of 10 to the 7th is like 3. It's like in worst case we have 20 here, and that's 2 to the 20. I thought this would barely work, but seems not. Okay. Well, as you can see, these does passes the test, but it's just too big, and there is a simpler way to do this. And if you think about it, let's imagine we had a task to check if number is a sum of powers of 2. What would that be? So let's imagine I have 8 plus 4. This is example of number that is, and let's say 8 plus 3. Or actually this also is, but we have to have them distinct, so that would be 6, 7, 7. Yes, 7. So 15. 7 is, oh, I can actually, okay, I can't use logic I thought I would use, but it seems that every number is a sum of, okay, I found one. So let's imagine I have a 10 and I have 14, I suppose, and I have 14 I can do. Even 10 I could do. Yeah, what's wrong with me? So 8 plus 2. Okay, wrong idea. But essentially, it seems, and it really is so. So each number, that's interesting thing actually. So every number is a sum of distinct powers of 2. That's pretty nice property of each number, because each number can be represented like this, and this means we use that power or we do not use that power. But the brilliant idea behind this task is, well, what's the equivalent for the sum of powers of 3? So powers of 3, that's this. So representation of the number at the ternary representation, whatever is the name. But when you see this number, you actually see something. So you use 1, 3 to the 0, plus 3 to the 2, and you see here number 2, and this means that to build this number you have to use 2 times this power of 3, and that's essentially it. So to solve this problem, we just have to uh, we just have to divide by 3, So res is equal so we divide by 3. We essentially shift to the right. And if res yeah, this res can I do it like this? So res is by 3. Is this true or am I missing? So this will be 4. Zero, return true. I think this is it. 21 is 3. Is 7. And 0. This is 7 divided by 3 is this is 7. 7 modulo 3 is 1, but 7 divided by 3 that's 2. When was it 1? I don't get this. Oh, yeah. I'm pretty whack today, so this. Yeah, so as you can see, pretty short and it's really specific, so you really have to know what's the trick. But I'm thinking of the previous approach, the one that got time limit exceeded, maybe there was something that we could do to optimize it, but yeah, not sure. And essentially, so two interesting points. Every number, every integer is a sum of distinct powers of 2, and you can see that from binary representation. And that's, yes, only for binary. And for ternary representation, you have to check how many times certain power was used. So yeah, okay, let's see, time complexity. So in this case, this should be O of log of n, and space complexity is 1 of 1. So log and space of 1. Okay, I hope this was useful. I was a bit bad in this one, but I'm also on my path learning. So yeah, if you have any questions, leave them in the comments. I appreciate you following this one, and see you in the next one.